Okay, ladies and gentlemen, let's do number 3. So we have Tony. Tony is going to hit a golf ball. So he's going to hit it from here, and it's going to go up, over, and down. So we're going to have the ground here, and we're going to have the ground here. So notice that y is going to be the height of the ball above the ground, and it's going to start at 0, 0. And that makes sense because you're playing golf. So the ball is going to be on the ground. Now the y-axis, or sorry, the x-axis. Here's your x-axis. Okay, so what do we do now? Mark the x and y. I did. Calculate the y-intercept of this parabola. Well, a lot of people ask me what form this is in. And the truth of the matter is, it is in standard form. The only difference is c equals 0, which means if I look at this, I can tell that my y-intercept is the c value, so it equals 0. And that makes sense because it's going to cross right here. The height above the ground is 0. Factor the equation. So we're going to factor this. And we need to common factor first. This is not a trinomial, so we're going to common factor out the x. I'm not going to take out the negative 0.01. I'm just going to take out the x, which is going to leave me with negative 0.01x, plus 1. And what that looks like is, because if I was to extend it, it would be x times negative 0.01x, which gives me x squared, and it'll be x times 1x, which will be 1x. Something to remember that we talked last day is that this could be thought of like the following. We could think of this as being an x times an x plus a 1x. You'll see that I have an x in both of them, for which I could common factor it out, leaving me with an x on the outside and a negative 0.1x plus 1. And that's the idea of what's happening, okay? This is the idea. Okay, let me focus in a little bit more, and let me come in a little bit more. There we go. Determine the x-intercepts of the parabola. Well, I'm going to use the factored form. And we're going to set y equal to 0. So it's going to be 0. And we want to know what x values are going to allow me to have y equals 0. Well, the first one's fairly easy. If x is 0, then the right-hand side will be 0. But the other one's a little bit more difficult. We'll have to do a little bit of algebra here. We'll set the whole thing equal to 0. We'll take the 1 over to the other side. And then we'll divide both sides by negative 0.01, which is going to be 100. All right, so now the vertex. Well, the vertex is going to be along the axis of symmetry. And the axis of symmetry is going to be halfway between here and here. Now, I didn't put on this. This was going to be 100, 0, and this one again is 0, 0. So halfway between 0 and 100 is going to be x equals 50. So we know that my vertex is going to be 50, k. I need to come up with that k value. So axis of symmetry is going to be x equals 0 plus 100 divided by 2, which is 50, which means that my vertex is going to be at 50, k value. We're going to sub x equals 50 to determine k value. Now it's up to you. I can plug it in here, or I can plug it in here. I'm going to plug it in this one this time. So it'll be y equals negative 0.01, 50 squared, plus 1 times 50. My calculator, so it's going to be 50 squared times 0.01, and that's going to be 25, negative. Plus 50 is negative 25. So my vertex is going to be, oh, not negative 25, sorry, it's negative 25 plus 50, so that's plus 25. So it's going to be 50, comma 25. And so we can finish this up here, and our vertex is 50, comma 25, meaning that the maximum height is 25 feet. So how far from Tony does the ball land? 100 feet. And what is the maximum height of the ball? 25 feet. All right, go do the next one, and we'll be back.